So you want to compile the Linux kernel yourself. So no matter what your reason is, be it simply that you want a newer kernel version than your distribution currently offers, better performance, by the way, this varies depending on your hard and software configuration, more flexibility, or simply out of interest in having it done at least once in your life, you've come to the right place. So here we are at my beautiful Linux desktop, and as you can see, this is what we are working with today. I'm using Debian testing as always, by the way. My Linux kernel at the time of filming is 6.12.22. Basically this is the newest kernel the Debian testing repos provide you with as of today. I also have a beefy CPU, a Ryzen 9 5950X, 16 cores, 32 threads, and an Nvidia GPU, which is important if you are using the proprietary Nvidia drivers. You have an extra step that you have to do if you want the kernel to work with an Nvidia GPU, or also other stuff like the ZFS. But more on that later, and let's get to the beefy stuff. By the way, this video mainly applies to Debian and Debian based Linux distributions like Linux Mint or Ubuntu, but you can use this tutorial even on other distributions. But keep in mind, some of these steps may vary, like installing the dependencies, which we will do next, and generating a new grub, or to be more precise, a new bootloader config with your new kernel in it. So yeah, if you're likewise on Fedora or OpenSUSE or Arch, anything else than Debian, Ubuntu, or based on them, use this guy as a reference and look into the It's Forced guide on how to compile the Linux kernel yourself. They gave the basis how to do it on Fedora and Arch. So now that you know that, you can grab the commands from my website also, but like I said, the dependencies I'm using here are the dependencies for Debian, or if you're on a Debian based system, you can see I have all of them installed. You can go to my website, which I also have a full guide on how to compile the Linux kernel yourself, but for the time being only in German. You might see the full guide in English later down the line. And yes, indeed, as you can see, my website is now also in English. So if you want to copy the commands or read the text guide through yourself, you can do it in English or also in German. I was also a little bit surprised that I could pull it off that fast. So now that you have the dependencies sorted out, you can go to the Linux kernel website, which is kernel.org, download the Linux kernel from the big yellow button. And here's the first step where it's depending on you, because most of the stuff I compile, which is basically just the Linux kernel and fast fetch, which I do with a script, by the way, look at my dots files, in my downloads directory, which is in my home. But if you want to do it properly, compile it in user/source, just download it quickly, and we can now go to a terminal. You now have to go to the directory you've downloaded it, like you can see here. And first of all, we have to decompress our Linux kernel with onexe linux-star.tar.exe. The star meaning basically whatever is in here, so the command isn't like version specific and you can use it always when you compile a newer or even older version of the Linux kernel without having to every time specify the Linux kernel version you're compiling with. We now have that, but we also want to check if our Linux kernel doesn't have a virus or isn't correctly signed. And you can go to the Linux kernel website and copy the URL from your Linux kernel version, which you saw here, but you can also download it here. It's the same thing, but download the GPG verification with copy link, and now you just do wget and paste it right here. I've used it in the past, so here I just could complete it and change the version, and like you see, it's done fast and without a headache. Now that we have that, we can check if GPG2 sees the signatures of Linus Torvalds and Greg Kroah-Hartman, and yes, it sees them or imported them, and now we can verify it because we've downloaded the signature. And even though you can see warning, this key is not certified with a trusted signature, you can ignore that. What only matters to us if it's a good signature, it's literally above the warning stands good signature from Greg Kroah-Hartman. And you even can see when the signature was made. So yeah, now that this is sorted out and is good, now that we've decompressed the kernel, we can extract it from its tar format. And for that we are using tar -xf for extract and f for file, and specifying the Linux kernel.tar with an, like I said, a star to make it more universal. And like we can see, we have the directory here, and you can see the directory in it using also the star, which saves you a lot of time. And yeah, we now can come to the beginning of optimizing our Linux kernel, because all Linux kernels have a .config, basically, like the name suggests, a configuration file, which in your case, if you're using only this hardware and never upgrading it, or just only has one specific use case, you can strip it down by a lot. You have more options to do that, because like you can see, in our case we don't have a .config, and you either can copy the current configuration of the Linux kernel, and of course the terminal bugs out because the line's too big. So basically sudo copy, so sudo cp /boot/config and minus quotes $ in brackets uname -r end of quote space .config. You can copy your current Linux kernel.config which you're currently using. So if I again do a fast fetch, or like I said, fast fetch pulls it from uname-r, you can see I'm using here 6.12.22. and if you're doing it through this way, you must update the config. Like you saw, this is like a big jump in versions. You can see it even has some warnings, but yeah, we will see if we can just ignore them and sleep well at night, or because of that it will not build the Linux kernel. But also, if you just want a clean config, you can also just make a dev config, so default config. But yeah, I'm using here the current config of my Linux distribution's kernel, even though I had my own compiled Linux kernel beforehand with a config. I deleted it for the German version of this video by accident, and yeah. So if you're, like I said, on Debian or a Debian based Linux distribution, you also have to do a step specific to just them to disable the module signatures. Because without it, your kernel won't boot or even at all compile, because it will search for that signature, which you can't find easily, and yeah, it's just a headache. So better just do it that way, and you can have peace in your mind. Also, before version 6, so Linux kernel version 6.5 point anything, it looked more like that, but after 6.5 upwards, you have just to do a one-liner, and this disables the module signature. But yeah, now we can come to the optimization and configure our config, where you can make the optimization. So in general setup, we can configure a little bit of stuff. Here you can see local version. So basically you have a version name, or you have the Linux kernel version. So in my case it would be 6.14.5 minus Jakub, and this is also like an aesthetic thing, but also can help if you're having the same version provided by your Linux distribution, that they don't collide or don't beat the shit out of them because they have the same name. And yeah, it also looks better if you just have your name in your Linux kernel. But yeah, you can see the Linux compression mode is CSTD. That's perfectly fine with me, and in my case I will disable all of the kernel compression besides CSTD and XZ. because XE by default is used for the Linux kernel modules. And yeah, even though you can switch that, I didn't have success beforehand, so I am going here the safe route. But you also can here lower the values of the kernel buffer. I'm just gonna lower it with a conservative 16 from a 17, like you can see here. You see 16 is a limit of 64 kilobytes. Other than that, we don't have anything here. And if you are having trouble to move the menu, you can use the arrow keys, and also if you need help, you can see how to navigate the anchors menu here, because it stands here. So we had just that, so configuration, we actually just wrote stuff in them, but you're gonna see in the next step, like here with Intel low power subsystem support. I'm, like I said, on a AMD CPU, and for me it's smart to disable stuff I won't use and will never use on this machine, because I'm not here on an Intel machine, and this kernel will never touch an Intel machine, specifically just for my machine. So in my case, I can disable it with N, and if you want to enable something, you just press Y, but disabling this doesn't work. And if you want to modulize something, you press M for modulize. And you can't really disable all things, or you have to disable other things to disable an option. So yeah. Also by processor family, you can see we have a generic 8664 CPU. If you're on Intel Atom or Core 2 Duo, Intel Core 2 Duo, or anything other than that, all the AMD CPUs, you can choose your options here. But I'm here on a Ryzen. Even my younger self who compiled the Linux kernel on a first gen Ryzen, so Ryzen 5 1600, just used the generic x86-64 processor family, and it worked, no problems there, and it actually was the option you would use. But yeah, I can disable the Intel MCA features, leave on the AMD ones, and going completely down here, like I'm seeing here, that should be everything, because in one category you're disabling the most stuff, so the first ones are going to be really small or just minor ones. But yeah, mitigations for CPU vulnerabilities, I don't know anything about that. But in power management and ACP options, suspend to RAM and standby, because here I'm on a desktop, I will disable it. But I heard that hibernation on laptops is good, besides other defaults like sleep, so you would leave that on. But like I said, I'm on a desktop and I'm leaving this stuff out. And CPU idle for driver for Intel process I can disable here. And this just a thing that if you know the kernel options, which you can learn by watching videos like that, or videos of other creators like Mental Outlaw, Denshi videos, or DJ Ware, which are by the way linked in my website's guide how to compile the Linux kernel, so you can find it. By the way, it's in a video description. But yeah, bus options, can't really change here anything. Binary emulation also not, and virtualization, you could lower the option of maximum number of vCPUs per KVM guess, but I would leave that or just switch to 1024, which is still a lot, and this machine will never have it, but I will just do it like that, but because I don't know better. But you can see what it might do while clicking H. So KVM max number of virtual CPUs sets the maximum numbers of vCPUs per KVM guess. Larger values will decrease the memory proven of each KVM guess, regardless of how many vCPUs are created for a given CPU. So yeah, basically this option is a good thing for optimization. We could even go lower to, let's say, yeah, we are going to set 520, 512, which isn't valid, so 1400. We'll leave it at that. So yeah, the memory footprint should be less for virtual machines. And of course you have to test it later if it really does something or just is a regression and it's better to leave it on or leave it at standard values. But yeah, general architecture dependent options, don't really have anything here. Enable loadable module support, and here in the module compression type you can change it to ZSTD, which I'm also going to do because it's Saturday and so I can go back to the general options. But if the Linux kernel won't compile, I know what first of all to change. Enable the block layers, don't know really anything about it. Executable file formats, looks good. Memory management, also leave it as is. Networking support, you can learn from the other videos I linked in my website guide, because you can improve and enable stuff here, but this is more part of lower level stuff. But when I'm here, I'm going to enable the Android open source projects extensions, so this will work. By the way, even though my motherboard has Bluetooth, I don't use it, and for that I have it disabled by startup through KDE, so you can just disable the systemd service or do it per GUI in KDE settings, and that's the way I did it a long time ago. But now we're going to the big boys. The device driver category you can look through. If you have an NVMe, you most likely want to enable this, even though it's modular. I will leave it like that. Mixed miscellaneous devices for the most part are, like you can see, disabled or modular, so we can leave it like that. And Macintosh device drivers, basically you can disable that if you're not on a Macintosh. Multiple device driver supports and RAID LVM looks fine to me because it's modular, so can just leave it like that. And like you can see, we have here a second networking option or category, but for devices. And yeah, if you're on a laptop and your compiled Linux kernel doesn't work with Wi-Fi or Ethernet, you will most likely want to look in this category or the other one and search it depending on your networking cards, so you have working internet or Ethernet. But Ethernet usually works and Wi-Fi is more the problem. But input devices, you can also disable touchscreens in this case. Miscellaneous devices, I have to look. You can see it's a lot of specific devices, mostly laptops, but also some stuff sounds weird, because like a Philips USB RF remote controller. Though PC speaker support would be the only thing I would leave on. Yeah, so basically you can leave that as modularized. Tablets, especially if you're using a graphical tablet to, you know, draw stuff digitally, you want to leave that. If you're not using one, you can disable that. But yeah, generally joystick, gamepads and mice and keyboards, it's better just to leave them on and don't experience anything, any devices to not work because you didn't want that for like 2 megabytes of more RAM you can use. So yeah, we can now go further down and search for, if I can find it. Yeah, so you also can disable Microsoft Surface specific drivers. You can see which one it targets. Here it's just a Surface 3 specific one, but these most likely are for the others. So yeah, you can disable them. And now to the really big boy, the x86 platform specific device drivers. There you can disable a lot of stuff, especially if you're on a desktop, even if you're on a laptop, you can disable the Xiaomi YME key driver. Same for the Gigabyte one, and yeah, generally you can just spam through it. And if you're on a X3D CPU, so AMD Ryzen with X3D cache, you might want to enable this option. I'm going to modulize it because I have a AM4 system, and if I want to throw a CPU with the 3D cache in it, I can. So yeah, Apple Gmax driver, basically you just have to disable it. If you're on a Dell laptop, you can see here the x86 the platform specific device drivers, because AMD, as far as I heard or learned from Denchi's video, it was so that AMD usually open source a lot of stuff, or helps at least with the development, get the devices working. But yeah, you can disable the other stuff which doesn't fit your use case or device, especially like if you don't plan to upgrading it, or know you're upgrading but still even after the upgrade these use cases or drivers won't be needed. You can just disable them. And so on the other side, if you're on a laptop, let's say a ThinkPad, you want to enable your ThinkPad specific device drivers if you are going to use them. The MSI stuff I would leave on because I'm on MSI motherboard, so I'm only disabling MSI extras. I will take a look at the YME stuff, which is say Y here if you want to put YME based hotkeys on MSI. Yeah, so basically you can disable that, or I can, and disable also that because it's a laptop specific thing. And yeah, so basically it goes further like that, just disabling stuff. Also you have the x86 tablet support, you can leave on, or I will leave on, because even though I don't use Android tablets, even just to record this video, I'm using my mobile phone, which is a Samsung S23, which of course is using Android 15 now, by the way. Just for it to work, I leave it on. We now see we basically just disabled most of the stuff. The specific one I forgot. I can disable those even though they were modularized. Other than that, you can look further yourself, or watch the tutorials of others, how they configured their .config. And yeah, basically here I'm going to enable Android support, are just basically some extras, if I'm correct. SoC system on the chip specific drivers, yeah, can be disabled and are disabled. And file system is also a category if you are using a lot of drives, or a colleague has a failing drive or broken one and you want to rescue his data of it. You might want to look in which file systems are built within your kernel. And yeah, so most of the stuff is, like I said, modularized. You can leave it like that. If you look further, you can also find CD-ROM file systems and Windows, or even pseudo file systems. But yeah, the DOS FAT, especially FAT32, can't see that. But NTFS file system support, I want that because my second drive is a 2TB hard drive, so HDD, not NVMe SSD. It's formatted with NTFS, and these other options are not exactly needed, but I'm going to enable them. Network file systems, if you're using an NAS or building one, NFS, you have it. And basically, other than that, security options, I don't really have anything to say or change here. Cryptographic APIs, the same thing. library routines the same, and kernel hacking also. So yeah, if you are done with customizing your Linux kernel config.config, you can save it by clicking the left or right arrow keys and moving here down in the bottom. You can save it as a .config. It's written, the changes were written to the .config, and you can exit with escape or at the bottom. And if we do a quick clear and show what files are here, you can see we have a .config and .config alt. And if you leave that .config alt, you will generate the same Linux kernel when you compile it with a .alt, which is basically the same Linux kernel but with the old config. So if your kernel fades, the .alt will also fade. Yeah, so basically I remove it. It makes my grub boot entries look cleaner, and I'm also not using it. So just sudo remove .config.alt. But yeah, we can clear and go to the compiling part of the tutorial, which you are here for. And depending on your hardware, like you saw in the intro or after it, I have fairly enough beefy parts. If there's some dude compiling the Linux kernel on a Threadripper or Epic CPU, it's even faster, but I can compile the Linux kernel in like 16 minutes or so, but I can't do it that fast if I'm explaining it. So basically what we are doing here, we will be using make dash or minus j $, and in brackets nproc, which like you can see is also like just using a variable, or we'll just input the output of nproc, which shows you how many CPU threads you have on your system. And basically we are going to put 2 smaller than end in 1, which should help with t-logging it. You can experiment without adding it to the compiling process, and pipe it to t-log to create a log file. But yeah, like you can see, the Linux kernel is compiling it, and we will see us in a few minutes. So now that the longest part of the compilation, or the longest compile, is done, we can move on. And by the way, if you're on ARM, so a Raspberry Pi or RISC-V, your PC needs, or PC architecture needs device tree binaries. So in my case, I don't need them because I'm on x86, but if you're on ARM, look at the part from its force guide, which is by the way linked also on my website. And yeah, but other than that, we can compile further. We can specify just a part of the Linux kernel, so we make the BZ image. So basically, if that is done, we can compile further stuff, and you can compile with this command sudo make modules underscore install dash $, in brackets nproc. We will compile the Linux kernel modules, which will take a little bit, but not long. Now that that is done, we can compile the last thing, which are the Linux kernel headers. And I before didn't use with -j, but in this part I'm going to compile it on all threads, and like you saw, it's damn fast. Now that we have all that compiled, we are coming to the step where if you're an Nvidia user, especially if you're using the proprietary Nvidia GPU driver, you must do the step, or else the compile won't work, or even if it somehow works, the kernel won't. So for that we just make the dynamic kernel modules, which like the name suggests, dynamic, which aren't directly built in to the Linux kernel modules. We make sudo dynamic kernel module modules, so they DKMS, auto install -k and our Linux kernel version, and if you have a local version or name appended to it. You see it's -Jakub in my case because I set it in a .config like that. That will build the modules for the Nvidia drivers for the Linux kernel. So yeah, like you can see, this installation of the dynamic kernel modules for our kernel succeeded. If your last line of this command says auto installed failed, auto install on this kernel, failed for modules this and this, so Nvidia-current and loopback, you are basically just if only your Nvidia driver or loopback device isn't building. It's also not ideal and won't work, so even if it's just a loopback device, both must build. And here, because I'm on Debian testing using the Nvidia drivers from the repos, Debian repos, sometimes with newer kernels this doesn't work, and if I wait like a version or two, like most of the times I just have to wait so that 6.14.6 would be released, or even at some point it was that the 6.13 didn't want to compile, and 6.14.1 also didn't want, because the freaking looped back device didn't succeed, even though the Nvidia current device and Nvidia current module succeeded. So yeah, that's like depending on your distribution and Nvidia driver, this will affect this step. But yeah, also if you are a ZFS file system user, you need to build dynamic kernel modules. But other than that, we can finally install the Linux kernel, and also just pray that it does work and succeeds. Like you can see, it works, and we now just have to boot into it. So see you after the reboot. Yeah, so now we are back on my Linux desktop, and let's do a quick fast fetch. And as you can see, our new kernel works. It's 6.14.5 minus Jakub. In the best case scenario, you would test it out if you made a comparison before, look at your RAM before and after, so with a standard kernel from your Linux distribution and now with your own compiled kernel, you would compare the memory usage, but also look if normal applications, audio and so on works. It usually works, but it's still a good practice to test out if it works, if something doesn't work. But yeah, let's get to the last two parts before the end, and the first one being how to remove your own compiled Linux kernel, whether it doesn't work or you just compiled it and compiled 2-3 others even, and they've become old and you want to remove them. So, and to do that, we need to remove the files that were placed in the directories when we executed sudo make install. By the way, also this is more of a manual uninstall because there isn't a sudo make uninstall, so we essentially just have to delete those files placed by sudo make install in the respective directories, and you can see those files in a /boot directory, to which we will get on in a second. But first of all, we will delete the Linux kernel modules for our kernel. So to remove them, we just do a sudo remove -rf, so to remove them recursively, and forced /lib/modules, and we specify our Linux kernel version. In my case, it was 6.14.1. And if you're on an ARM or RISC processor and compiled the device tree binaries, just quickly remove them with that command, of course with your exact kernel version. And now let's come to the big boys. Especially in the /boot directory are most of the files created or needed for a Linux kernel to work. And as you can see, there's a system map, VM Linux, initrd.image, and a config for every Linux kernel version you have on your system. And to remove one kernel as a whole, we have to remove all these files for one specific version. And we can accomplish this by executing this one specific command, which is at the end you see system.map, initrd, VM Linux. It just makes that we can delete all of these 3 files, in this case, even 4 if you have the device tree binaries, with one command. And after that, of course, don't forget to replace my command with your exact Linux kernel version. I also added a star at the end to delete the normal kernel and the .old kernel, which, like I said, is created when you leave a .config.old. However, it's generated if you just upgraded your older config of your kernel or saved a modified config through the make menu config. The .config.old is automatically created, and if you leave it there, also the .config.old kernel will be installed. So that's why I use the .star at the end to remove them simultaneously. Now let's come to the troubleshooting part. By the way, I couldn't be bothered to resync this part or do a voiceover for it. So essentially, if you have issues building your kernel, look at your .config, look at the error messages. So sometimes the error messages gives out what the issue is. If it doesn't, because sometimes the error messages are arbitrary, then Google it, research it, find if someone had this issue, or it's like a stupid little thing. And yeah, it actually comes in this part down to your troubleshooting skills. If you experience some issues, if you're doing it for the first time, or if this issue is documented or you're the first one to explore it, or just anyone who had this issue didn't bother to document it. So yeah, that's it. But also, if you want personal support while switching from Windows to Linux, from me, it's the first link in the description. But other than that, you can like, subscribe, and leave a comment. And besides that, we will see us next time. Bye!